So today's subject, what we're going to do is take a look through the Seabee book, Building the Navy's Bases in World War II, Volume 2. And a lot of these you're going to find are reprints. This one was reprinted in, I believe, 2011. Basically, this is going to talk about the bases that were built to support the U.S. Navy all over the world. And to me, this is an idea book. What they're doing is kind of giving you a history, how and where things were constructed. But what we're going to do is look through the pictures and look at ideas. And we're going to talk about what we can do in SHTF based on what they did in their SHTF of their day. Now, unfortunately, this publication doesn't have a military ID number for it, so you're just going to have to look the title up. But the first thing I want to talk about is in SHTF, we're not going to have any air conditioning. The second thing is, if you have any electricity at all, it'll be very limited. So you're going to have to be careful what you use electricity for to conserve it. Now, because most of the United States is either a hot climate or has a part of the year that is hot, what we need to do is look at how we ventilate things without air conditioning. Because if you don't have any air conditioning, you're going to have to use natural ventilation or mechanical ventilation. Now, in the past, in different countries, they used a series of weights to operate fans instead of electricity. Those are mostly antiques now, but you can still find enough examples where you can build them. Now here we're looking at a naval training facility that was built in the early days of World War II in Hawaii. And you can see here the amount of windows, and you'll notice a lot of them are mounted high up. And the reason is a lot of the wind that flows across the ground, it flows up to 20 or 30 feet high. And in the South here, during the Civil War and up until air conditioning, they used to put a lot of high windows in. And one of the reasons for that is the insects didn't fly 10 to 12 feet off the ground. So most of the insects fly lower to the ground. So one way to reduce the amount of pressure against your screens is to put them high. And that will help ventilate your home and prevent insects from entering. Now, this photograph is on page 186. This is a naval hospital, and you can see how it is inside of a triangular compound here, inside of a base. Now, one person I knew that was in Special Forces in Vietnam, what he did is he built a triangular small base inside of a large air base that he and the Montagnards had to defend. And if you look here and you keep in mind a triangular base or compound or group of buildings, that gives you the maximum amount of area for the least perimeter to defend. And if you were using this as your base, you could put wire and berms along here. And if you put one high firepower weapon here, one here, and one here, and instead of shooting this away, you shoot down the embankment or the wire, you can break up and prevent mass attack. This is especially useful at night. So one thing I want people to keep in mind, if you don't have many people and you don't have a lot of construction ability, if you have your defended area in triangular form, that will give you the least perimeter for the most area inside. So it's easier to defend. Now, this photograph is on page 222. This was from the Pacific Islands. And what this is warehouse storage area. So what they did is they built up this side, or they cut part of a hill down, and then on this Quonset hut, they built up the area. They built the Quonset huts up here, and the causeway in between is actually the loading dock. So you can do your earthwork this way where you'll notice you have a nice loading dock on this side, and if you play it right, the other side will be level to the ground. So you can back trucks up in here, or you can drive up on the back of the loading dock and enter the buildings. So this is a really easy way to make a good logistics loading and unloading area. So on this side, we're utilizing a loading dock at standard truck height. On the back of this structure, it's level with the ground. That way we can access it from both sides. This is a photograph on page 281. This is a causeway, and it's set up as a dock and an access. And we've talked in depth about making sheet pile walls, cribs, and doing built up areas out of rock and rubble. And that's what they did here. So you can go into areas and you can actually build a causeway out into the water that acts as a bridge. You can make a T on that and actually make a dock area. Now you can use wooden piles with wood sheets, log sheets. You can use boulders, you can use riprap, you can use all kinds of materials to build these. I've built these in a lot of areas, mostly in swamps. Now, what I want to tell you is, for instance, if you were going to use this as a bridge, you could come along your causeway here, and if you wanted to allow the water to flow through and prevent damming, you could put a small bridge here. And by a small bridge, you could just do an 8-foot bridge, and then you could come a little ways over here, put you another little bridge in, and that way you allow the water and the tide to come in and out, and it relieves any hydraulic pressure you would have on your structure. That's a really good idea, but I don't see it used often. Now we're going to look at page 356 and 357. Two things we're going to look at is the method of construction and ventilation. Here we have Quonset huts, and you can see all the ventilation windows and screening here, and you notice how you have a louver over top of it. That keeps the sun and the rain out but allows airflow. Now we come down here, and this is a logistical area, and you notice what they did is they just built your standard pole barn to store stuff in. So you can use and utilize and adapt any type of construction, whether it's farm, homestead, military, urban, whatever you can do with the materials at hand is what you should do. Now, one way the military would take pressures off of the Seabees is they would partially build things with military labor and partially build things with indigenous labor. Now here, this is a recreation area, and this is all built by indigenous personnel under military contract using indigenous materials. So this is all straw roof, straw wall. So if you're in an area and you have indigenous materials and methodology that you can utilize it. Now, this is a really interesting photograph, and you don't see this much anymore. This is on page 366. And what they did here is they built circular cribs out of sheet piles and filled them with coral and rock. And they use that to build a causeway. Now in the past, what I've done is I built sheet pile walls and used buttresses on them and then filled it in with rock, gravel, etc. to make causeways. But this is a really ingenious way to do it because it allows you to work out on your platform really easily. So if you have ability to put piles in, you can actually put piles and connect them with logs or boards, or you can use sheet piles. And these cells, I believe, are like 30 feet in diameter. So if you want to use 20 feet, 10 feet, whatever you want to use, you can build a causeway or you can build a dam that way. So another idea. Here on page 374, we have more examples of a base built up, and we have a lot of ventilation. Here we've actually added a porch. We have these lean-tos coming off. That provides shelter from the rain and from sun. We have top ventilation here and bottom ventilation, so we can actually cause circulation to happen. The cool air comes in, hot air goes out the top. Keep this in mind when you're building your structures. On page 394, we have some adaptations that were made in the field where we added a bungalow front. So what we've done here is we added a porch, we added a lean-to, and we can utilize this to allow additional ventilation. And then on page 395, this is another example of upper roof ventilation and windows with screening. Now on page 406, this is a way that you can get away from having to use people to direct traffic. So what they did here on Okinawa is they built a traffic circle to connect all these roads. So in SHTF, if you have an area that's bombed out or destroyed, or you have roads tore up, if you have to make corduroy and improvised roads into these areas, you can always build a traffic circle at the center of a city or a center of an intersection in order to allow traffic to flow without traffic control. This is critically important if you do not have electricity or personnel. So on page 411, here we have another example of a causeway. And you can see here where we have a wood pile with wooden log structure building this. So you just build one on this side, one on that side, and you fill this material in. So this is another example that you can utilize. Now on page 254, I want to talk about this example of Quonset hut workshops. And what most people never think about is the necessity to be able to work and repair in all weather year-round. And what happens is you have a Quonset hut, and you can build a wooden structure, you can build a rubble fill structure, I don't care what it is, but by adding an aluminum or timber lean-to the side of it, that's an easy way to quadruple your workspace. You can put one on this side, and you could actually put one on that side when you plan this building. And what this does is allows you to do repair work when it's raining, when it's snowing, etc. So keep this in mind. This is going to be a critical thing in SHTF, because if it's 100 degrees outside and you have no air conditioning, no fans, this will allow you to work in the shade. It allows you to work in the rain. So keep this in mind. Just a few thoughts and ramblings for SHTF. Share your thoughts. We'll see you on the next video.